Mastery is one of our most important principles. I first started thinking of mastery probably 15 years ago. I discovered that when students come to the end of the year after a year's worth of study and we start thinking about the final exam review, they often can't remember even covering a topic during the year. So they're obviously unprepared for the final exam, and a week of review is not going to change that situation. So 15 years ago, I started thinking, what do we have to do? How do we change our pedagogy so that students reach the end of the year, and instead of forgetting what they've learned at each step of the way, they're retaining what they learned? I developed this saying back then called the Cram-Pass-Forget cycle to describe what I was observing. And I've seen this in every classroom, just about, in our country. Students cram for tests, they pass the test, and then about 3 weeks later, they forget what they crammed. So this to me is an exercise in futility, and it's a big reason why students are frustrated with school. So my vision was to figure out what do we need to do so that instead of students cramming, passing, and forgetting, they learn, master, and retain. So it took 10 years. But after 10 years, I developed a pedagogy and a way of approaching assessments that is geared toward mastery. Now, here's what I mean by mastery. I mean students remember what they've learned throughout the school year, and that even after the year is over, they will continue to retain most of what they learned that year for years afterwards. In fact, I discovered after having implemented the new things that I was working on, that students I taught in 9th grade for introductory physics would show up again in my class in 12th grade for their senior physics, and they remembered probably 3/4 of what they learned in 9th grade, all of which meant that I didn't have to teach them that material over again. A brief review, and we were ready to go with more advanced material. Now, there are several fundamental components that have to be in place to operate a mastery program that's going to function like this. The first is placement criteria. Students cannot be expected to master what is unfair to ask of them to master, but if they are properly placed in a course that's designed for them, then it's not only fair to expect them to master the material, it's actually a disservice to the student if we expect anything less than mastery in a case where they are properly placed in their class. The second thing that has to be in place for a mastery program is that the curriculum itself has to be culled down so that the body of material that's going to be addressed during that year in the class is a proper amount to master. In most cases, with textbooks these days, that's not the case. Most textbooks, 2 or even 2.5 inches thick, 600 or 800 pages worth of content, 40 or more chapters. There's no way a student can master that much material in a year, not even at an advanced level. So culling the curriculum down to basics that are the meat of the class, and of course there are other things that are there to enrich the experience in the class, but the major content is culled down to what the student is expected to master in the year. So proper placement, culled curriculum. The third aspect of running a mastery program is the teaching practices. Teaching practices need to be geared with mastery in mind. So to start with, that means communicating clear learning objectives to the student at the beginning of each chapter. As a student, I need to know, what is it that you want me to master? It's no good to say, read chapter 5 or the test will cover chapter 5. That is not a specific learning objective. But specific learning objectives such as calculate density or explain Faraday's law of magnetic induction, those are the kinds of specific objectives students need to know. In addition, students need adequate time to practice what they're learning. If mastery is to be expected, then a few quick homework problems that we rush through aren't adequate. Most things require much practice for students to obtain mastery in the first place. And then there need to be subsequent practice exercises on the same material throughout the year to retain the mastery that they attained in the first place. In addition to adequate practice, we have review that goes on throughout the year. One of the things I like to do is provide weekly study guides to younger students who are in the, say, 7th through 9th grade range, so that they are being encouraged to review and practice the things they're supposed to know already on a weekly basis, so that that knowledge doesn't slip away. And finally, always providing the answers to students when they're doing objective types of problems, computations, so that they know on the spot that they've done the problem correctly or incorrectly and can make compensation at that time. The final component of a mastery program is the assessment practices, and this is one of the most important things about the program. One of my major discoveries is that a weekly cumulative quiz in the 7th through 9th grade will revolutionize the way students remember things. When I say cumulative, I mean a quiz that covers everything from the beginning of the year until the week before that quiz. So I began structuring my weekly quizzes so that they didn't start and stop with chapters in the book. The chapters in the book, we went through them as we will. The quizzes occur every week at the same time, and they cover everything that we've done in the whole course up till this point. And the students, by studying appropriately, are being called upon to be tested on that same material week by week, which is increasing as we go. That completely revolutionized what students could remember by the end of the class. In addition to that, there are some other techniques that should be embedded into the assessment process. One would be to embed lower level skills into problems that are addressing higher level skills. For example, putting unit conversions into problems requiring scientific notation in problems, things like that. So these are things students learned earlier that they're being called upon to use over and over again. One final component to an assessment practice that's designed for mastery is to essentially eliminate credit for homework in the grading of the class. Homework is a necessary learning activity. It's not a legitimate assessment of whether learning has occurred. There are too many ways to get homework done. You can have help from your friends, help from your brother. You can look up the answers and reverse engineer the problem. There are many ways to get homework done. Turning in a homework paper does not indicate that you've learned anything. So it's necessary, but it's not adequate. And the place to earn grades is on quizzes, tests, and to some extent lab reports and other projects. So I advocate a very minimal amount of grade credit in, say, middle school, 5 or 10% for homework. Phase that out in 9th grade, and in higher grades, eliminate the credit altogether. So parents get on board by learning that, yes, we do require the homework to be done, but we don't give credit for it in the grade. So you put these together. You properly place a student in a class that he or she has the potential to master the content. You cull the content down to what can be mastered in 1 year. You adjust your teaching practices so that they're geared around review and drill. And then your assessment techniques are geared toward mastery by constantly requiring students to show again that they can still answer the questions, they can still solve the problems that they learned in previous chapters. Our textbooks are designed to support a curriculum like this. And by the end of the year of using a textbook that's designed this way and designed to support this kind of learning, our discovery is students will remember what they've learned for a very long time. Things that they have forgotten can be quickly relearned within just a few minutes. This technique actually works. It works very well.